acids. So carboxylic acids have a general formula of CnH2nO, whereby N can start from 1. So the functional group of carboxylic acids is made from your carbonyl group. So it is from a carbonyl group. Let me get the highlighter there. So now this is from a carbonyl group and a hydroxyl group, giving you what? A carboxyl group over there. So now, the suffix for a carboxylic acid is always going to be what? Oic acid. And then now a few molecules of your carboxylic acids can be your methanoic acid, it could be your ethanoic acid, and your pentanoic acid like this. Notice, just like the aldehyde, this molecule, we can play with this C double bond OH. So now this double bond O we can put here, we can put the hydroxyl group over here. We can have another molecule whereby we play with this guy, and then we have this as a branch molecule, but then we can do this again and we put the C double bond OH like this. This is still the carboxyl group, and then be very careful when the examiners give it to you like that. So that is it so far about your carboxylic acids. Your carboxylic acids, one thing is that when they react with your alcohols, they give you what? They give you esters basically. So now we have your esters right here with your general formula being CnH2nO2, whereby now your N starts from 2. So for you to have an ester, you need to have at least 2 carbon atoms, because now we identify an ester by having an oxygen in the chain basically. So you have that this could be the carbons in the parent chain on the left and the carbons in the parent chain on the right, and then you will see this oxygen in between 2 carbons. Then you will see that, oh, this is actually an ester. So now, as we said, esters are made from your alcohols. Make sure, guys, that you remember it is going to be a primary alcohol when we are making your esters over there. So now we are going to have primary alcohols, and then now with this oxygen that we are focusing on right here, on the left hand side, if you do not have a double bond, that is your alkyl side, which is the side that came from your alcohol. And then now the side on the right, which has your carbon that is double bonded to the oxygen, now is going to be the side we call the acyl side, and that is the one that comes from the carboxylic acid. So be careful when they now take this molecule and they switch it around. Maybe they take the oxygen, put it on the left, and then you have your alkyl group on the right. Remember, when we speak about an alkyl group is just like an alkane. They are just like an alkane minus one hydrogen atom. So minus one hydrogen atom. So that is what's happening when we're speaking about alkyl groups. They are alkanes missing one hydrogen atom. And then, yeah, esters, as I said, they are made from your carboxylic acids and alcohols. So now, as they are made from carboxylic acids and alcohols, it is this process that makes the esters, which is the process we call esterification, or sometimes it's going to be called condensation. So even when you are answering your exam type questions there and you provide us with the condensation name for the process, you will not be penalized. So now, here, when you are doing the esterification process, you will see when we deal with the esterification process in its own video that the alcohol over there will lose its hydrogen and the carboxylic acid will lose its hydroxyl group as a whole, and then that will result in what? That will result in the ester that you're going to have here, which is methyl ethanoate. There are some other molecules that you can have just like this, your propyl ethanoate, and your ethyl methanoate. So now, for these videos, we have covered all of the homologous series that we have, how you can identify the homologous series, and how we know their general formulas. So now, basically, in the next videos, now we are going to be covering your naming of your homologous series. So we're going to be doing IUPAC naming. Let us go, guys. Let us do it. Thank you over there. Don't forget to subscribe there on the videos and like the video. Thank you.